scope. Limit of resolution. The smallest angular separation between two distant objects whose images can be just resolved by a telescope. It's called a limit of resolution. So I directly say, what is this d theta? 1.22 lambda by capital D. What is D? No. What is lambda? Lambda is the wavelength of the light emitted by the star. Usually telescope, what we use to view the distant stars. And what is the D? D is the aperture. Lambda is the wavelength of light emitted by objects. And what is capital D? Capital D is the aperture of the lens or diameter of the object. Better let me write here. Diameter of objective lens of telescope. It directly depends on that limit of resolution. And the reciprocal of this is called as resolving power. So resolving power, the symbol is RP. There is no any specific symbol. Let me just introduce resolving power P. So this is equal to 1 by d theta. And this will become d by 1.22 lambda. From where this is brought here, you just go back to the diffraction phenomena. We had a slit. Okay, fine. So I think we used to discuss some theory we have discussed. No, it is like this here. Can you remember all this? This one. This is the width of the slit, D. If it is if the rectangular slit, so what is this angular separation? I'll show that D here. So nothing new. The same old thing is what I'm putting one thing. So what is this theta? We used to write lambda by D, no? If it is a circular slit, it will become 1.22 lambda by D. If the rectangular slit, it will be lambda by D. Can you recollect? If the rectangular slit, if the circular hole it is, circular slit it is, then D is what? The diameter of the slit, circular hole. Then what happened? We introduce this as 1.22. This called like a limit of resolution. From here is what I'm bringing. So now you can ask questions, sir, from where you are bringing it here. The reason for this, why I'm directly writing 1.22 lambda, the limit of resolution. So you have to ask this one best question for a teacher. So actually, if you see the telescope, the objective lens of telescope will be like a slit, because what all the light emitted by the distant stars, they should pass through the objective lens of a telescope. So the objective will be like a slit. And what is the diameter of the slit? That is what the capital D is what I'm writing. In place of small d, that capital D is what we are writing it here. So then, so what is actually the telescope lens? If there's a telescope lens, I'm trying to give more theoretical information, because in books we have less diagrams. You find very difficult. That's why I'm just trying to give more diagrams, so they'll be easy for you. Now, what is this red color, blue color? They are the rays emitted from the distant stars. Light, this is star one. There's a light, star two. So the eye which is present here, and there's an objective of the objective lens. Then how the pattern, diffraction pattern, it will be. The minima, okay, the ear should be maxima, should be there, no? Okay, look at this. So where at this one. So then what happened? The eye will be present here. Actually, in on the retina of the eye is what I'm talking about here. Light from star two. Then this is the peaks. So I'm able to see that the maxima of the first star lies at the minimum of the second star. I'm able to resolve. The eye is able to resolve. So when the telescope produces the two diffraction patterns which are of this kind. And what is one more thing? The diffraction, what happened? Maximas, secondary maxima, minima should not be there, no? Will I agree, all of you? One more criteria. Otherwise, what happened? How the moon will appear? The moon will appear if there's a moon. If there's a moon, so along with this, what you'll get? You'll get a bright alternate dark, bright and dark this year. So what is that reason for that? What is the reason we have to give? We have to give reason that this is due to the diffraction or secondary maximus minimus. Tell me like what I should do. I should increase the diameter of the width of the slit. No? The moon, this is actually the moon. What are these rings? Alternate bright and dark rings. This is due to diffraction, secondary maxima minima. So if you increase the width of slit, they'll get eliminated. Then we'll get only central bright disk. So is this, if the pattern arrives like this, no? So it'll be very difficult, no? Suppose say like if you make observation of two distant stars, actually these two distant stars are there, no? I'll change the diagram. I'll explain according to that. Black color is needed. Overlapping, I think not possible. Let me try. It's minima, it should come at minima, no? Any of possible diagrams they can ask you. Okay, now the eye is able to say that telescope is very good, is able to, but what is the problem? These are secondary maximum minimas. What are these? Getting this one. So this should be unweighted. So what all telescope should do? It should see that the image formed by the two distant stars, all happen, there should be only central bright disk of the two stars and it should be that one. So what is, there's a one main minimum thing. And will you agree this two stars appearing? I think it will be very difficult, no? So therefore what happened? Even the telescope should see that this should be eliminated. What I should do? I should go for the aperture. I should increase the diameter of the telescope here, objective lens. Then what happen? Even this will get eliminated. Then note if I get only the 2 stars here, if I get only 2 stars like this, so this is the preferred one. So they may test you with questions of these kind. You have to be very careful. No. So definitely what you can select. It's a good telescope. Now 2 telescopes are there. Telescope 1 will produce this, telescope 2 will produce. Tell me which one you prefer. You prefer this one. Now there is another set of telescope is there. As of course, there is no diffraction pattern because the secondary maximum minima are eliminated. But what is the problem is like, oh, so sorry. No, what is the problem with this? So among these 3, which one you prefer? There's a very best telescope, no? This one. Ray optics is not valid. What about here? It's good telescope, but resolving power is very poor. Very good telescope, high resolving power, and no diffraction effects. Sure, I'll put comments here. High resolution and no diffraction effects. Then what about here? Poor resolution and no diffraction effects. What about this? Just resolved, but having diffraction effects. Tell me what all criteria you have to satisfy. What all criteria? It should have high resolution and no diffraction effects. Because of diffraction, maximum minima will come. So this is the condition for telescope is what we should design. Okay, why 1.22 lambda I brought it? Yes, it's able to resolve. So the reason, okay, justified. Why 1.22? If it were a rectangle, if the telescope, what I'm using, if it were of a rectangular shape, then this 1.22 will not come. This 1.22 will not come. Okay, able to get this one. If I use the telescope of this kind, I'll bring the diagrams here. It'll be easier. So there's a telescope. So there's a circular aperture. So what is the limit of resolving power will be? Resolving power will be D by 1.22 lambda. What is D? This one. Then I have another telescope where the length will be of like this. Then resolving power will become how much? D by lambda only. Or limit of resolution will be 1.22 will not come. The reason is the aperture. Circular aperture 1.22 will come. Rectangular slit. So the objective, there's an objective lens. The objective lens will be like a slit. Not the eyepiece, the objective lens. That's why the 1.22 is brought here. Okay, still I think most of you are like, why that, still that formula? What is the meaning of that? Okay, this is what I put it like this. So there should be the criteria for the objective length. You should be able to resolve. If it makes the 2 patterns overlap, then what happens? The telescope is unable to form 2 distinct images. There's the meaning of that. So directly let's go for one numerical so that it'll be easy for us. I'll start with a simple microscope, so like a human eye.